Hey, welcome back to Math with Patrick. Today is September 8th, and we're solving problem 251 from the Daily Epsilon calendar. And the answer today should be 8, because it's the 8th. And so it looks like today we have an arithmetic problem, kind of, where we have a long list of powers of 2. Interestingly, the highest exponent is the current year. And after we do all of this, I guess, subtraction, we are supposed to end up with just the number 8 today. And oftentimes, when this calendar brings in the current year as a number in the problem, usually it's just some kind of placeholder. Like, I'm guessing that this problem would have been the exact same had we started with a positive 2 to the power of, say, 2023, and then a whole bunch of minuses all the way down to here. Like, I don't think it's special at all that we're stopping with this exponent of 2025. Also, this wouldn't really be solved well as an arithmetic problem because, as you can tell, we have a lot of terms in our subtraction here. And I also don't really know what 2 to the power of 2025 is. This is that many 2's all multiplied together into some very, very large number. Instead, we need to think of some strategies about adding and subtracting powers of 2. So let's start small and then work our way up. I know that there's a feature of powers of 2 where if you just start adding them, so that's 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. If we add up all of these, it's going to be 1 less than the next power of 2. Because like this is 12, that's 3, and so 12 plus 3 is indeed 15. And it doesn't matter what number you stop at. Like this 16 could have been over here, and then this would have been 32 minus 1. And the powers of 2 just have this fun feature where if you add up all the previous ones, you get 1 less than the next power of 2. Or in other words, if I just tack on another 1 on this side, then this is a true equation. And it kind of works like not only like with this 1, but it works with any of the other powers of 2, as in I could have erased all of these. That's 1, 2, 3, 4, and then just tacked on a 4 right here. Or I could have erased both of these 4's and tacked on an 8. Or I could have just erased both of these 8's and tacked on a 16. And so there are fun patterns that happen when you're adding and subtracting powers of 2. So for this problem, I'm going to take a look at how much stuff we're subtracting here, and I'm going to take out the negative sign. And so I'm just going to assume that all of these terms are now positive or adding instead of subtracting just for a bit. And we're going to end up with 2 to the power of 5, 2 to the power of 4, and then 2 to the power of 3. And the sum now is going to stop there at 2 to the power of 3. So if you trusted what I just did with like the lower powers of 2, where I can just add on another one of these kind of lower powers, and then all of this now equals the next power. Like if you trust it for the small numbers, then maybe it would make sense that you could also trust it for the larger numbers here. So this sum that I now have on the screen right here is equal to 2 to the power of 2025 because I added on an extra 2 to the power of 3 at the end. So that means that if I subtract all of these, which is what we're actually doing from this problem, if I subtract all of these from 2 to the power of 2025, this now is just the number 0 because I'm doing some number minus itself. Although I'm not actually subtracting away all of this stuff in the original problem, right? I'm not actually subtracting away this. This doesn't exist in the current problem that we have here. So instead of subtracting everything away from 2 to the power of 2025, I'm subtracting just enough that I'm left with 8, which was that this is that 2 to the power of 3 that's going right there. So had I not scribbled this away, we would be getting 0 here because these two numbers are equal. But because I'm not subtracting the 8 over here, I am now left with 8 from this problem. So that's how I'm thinking about it. That's my solution for today. I think there's other ways to think about it too. We could have used formulas. We could have used some kind of summation notation with capital letter sigma. We could have thought about this in terms of binary, like zeros and ones. That's another way to do this problem. But this is this is the solution that made the most sense to me. So I'm all done. Hope you enjoyed. I'll see you tomorrow. Bye.